Welcome to Dakshina Engineering Junctions, and this is V Reddy. So, in today's sessions, we are going to discuss the daily practice problems on engineering maths day 3. Previously, we have discussed at day 1, day 2. These are the most expected questions for GATE 2023. Let's see the day 3 problems. As we are discussing daily problems on the probability, calculus, linear algebra. Five questions we are discussing daily. Now let's see the today's problems. Already shared the PDF and let us discuss one by one problem. Chalo. Let's see the first problem. Previous 30 problems we have finished. Every day we are doing the 15 problems and you can see the next problem. If A is a non-singular matrix means that is non-zero. Since the matrix is a non-singular matrix, so determinant of a matrix which is equal to non-zero. Data of a matrix is non-zero. Okay. And they are asking to find the what is the value of A square into adjoint A. They are asking to find the A square into adjoint A. So then which is given as A square into adjoint A. As we know, A inverse, which is given as what you tell me, which is adjoint A by det A. A inverse is given as adjoint A by det A. So from this we can get the adjoint of the matrix, adjoint A, which is given as what you tell me now here. I can say this as A inverse into data of the matrix. So I can replace now here, that is A inverse into data of the matrix. So A into A inverse, which is a I matrix, it will becomes A into data of the matrix now here. As we know, data of the matrix is a constant, right? So we can write this thing which is also equal to det A into A. As we know here, K into matrix, which is nothing but A into K. So multiplying with K, which is a constant. So option 1. Next problem. See this thing here. They given the condition ai square plus bi square plus ci square equal to 1 and aij bij bj plus cij equal to 0 when I is not equal to j. Now, so the condition what they given here, ai square means what now here, when I is 1 2 3, I can say this is a1 square plus b1 square plus c1 square, which is given as 1. Next, a2 square plus b2 square plus c2 square, which is given as 1, and a3 square plus b3 square plus c3 square, which is given as 1. And thereafter what else they given, you see, a1 a2 plus b1 b2 plus c1 c2, which is a 0. Next, a1 a3 plus, when I is not equal to j, b1 b3 plus c1 c3, which is 0. Next, a2 a3 plus b2 b3 c2 c3, which is also equal to 0. They has given like that. Like this we can write the things. Now you see the carefully. Now they are asking to find the data of the matrix. Now what I am doing is, and they given some matrix. Now that matrix I am taking as a A. So which is the matrix A? I am considering this thing as A1, A2, A3, B1, B2, B3, C1, C2 and C3. This is the matrix is given. That matrix I have called it as A. Now can you tell me the transpose of this matrix? So this is A1, A2, A3, B1, B2, B3, C1, C2, C3. Now here I am finding this thing A transpose into A. I am finding the A transpose into A. See what I will get now here. This is A1, B1, C1, A2, B2, C2, A3, B3, C3 into, so this is A1, A2, A3, B1, B2, B3, C1, C2, C3. Next, if we multiply these two here, see what I will get now here, this rows with this columns now here. So we will get first element as A1 square plus B1 square plus C1 square. Next, second element, what we will get now here, this is A1 A2 plus B1 B2 plus C1 C2. And third element, A1 A3 plus B1 B3 plus C1 C3. Like this will get. Now here second element, you tell me what I will get here. This is A1 A2 plus B1 B2 plus C1 C2. Next here A2 square plus B2 square plus C2 square. Next A2 A3 plus A2 B3 sorry B2 B3 plus C2 C3. Next one A1 A3 plus B1 B3 plus C1 C3, A2 A3, B2 B3, C2 C3. Next A3 square plus B3 square plus C3 square. Right, now as per the given information, as we know here, so this one here, all these values are zeros. Now tell me, all these values are zero since they given this as, so they given this condition is given now here. So Aij, I is not equal to j, which is 0, and when all the else same, we are getting it as a 1. So from this, these terms are zeros. Now you can see now here, that is A into A transpose into A. See what I will get now here. This is 1 0 0 0 1 0 0 0 1. So this is nothing but what now here, I matrix, identity matrix. So that means here what I can say now, this is A transpose into A, which is nothing but I matrix. A transpose into A, which is nothing but what you tell me, I matrix. Then, so what the data of the matrix is. So if I take the determinant on both sides, determinant on both sides. So what I will get now here? So A transpose into A, which is nothing but data of this I matrix is 1. So what I will get now here? So both dates are equal now here. So the data of transpose and A, which is equal to 1. So this means both the dates are equal. So we can say this is data of A whole square, which is equal to 1. So from this what I can say now, data of A which is equal to plus or minus 1. Plus or minus 1. And you do remember this thing as some standard result also. So if A into A transpose or A transpose into A, if this is equal to I matrix, then this A is called as a orthogonal matrix. A is called as what? Orthogonal matrix. If A is an orthogonal matrix, then data of the matrix A, which is equal to plus or minus 1. Orthogonal matrix determinant is plus or minus 1. So, third option. Fine. Yeah, I think you can easily answer this thing. So, just now we have discussed this thing now here. If orthogonal matrix, so A inverse they are asking. Now you tell me now, orthogonal matrix means A into A transpose, which is equal to what you tell me now, I. For orthogonal matrix, A into A transpose equal to I. Now I need the A inverse is required. I am multiplying the both side with A inverse on both sides. Pre-multiplication I am doing. That is A inverse into A transpose, and which is given as A inverse into I. So you can see now here A inverse into A, which is nothing but I matrix. I matrix into A transpose. So which is nothing but A inverse I can say. This is my A transpose, which is equal to A inverse. So you can see now here, for the orthogonal matrix, the inverse of the matrix, which is nothing but its transpose only. Inverse of the matrix is simply its transpose only. Fine. Next one. If A is a square matrix of order 3, A is a square matrix of order 3, now they are asking adjoint of adjoint A square. And so here you see this thing as we have the relations, that is adjoint of A power m if we have, which is nothing but what we can say this is adjoint of A whole power m, right? And so here we have this adjoint of data of adjoint of so let us say here this is some P matrix, and which is nothing but what we can say now here, data of P whole power n minus 1. So where n is a square matrix of order, whatever the order is given, that order. So let us consider this is n cross n matrix now here, where this n is given as a 3 cross 3 matrix. Adjoint of adjoint, so determinant of adjoint of P matrix is given as what we can say here, data of n minus 1, data of n minus 1 whole square. This is the standard result we have discussed this thing, right? Now you tell me now here, in place of P we have a, what we have here, you see, data of adjoint of, here we have A square is there. So then which is given as data of A square whole power n value, n is equal to 3 minus 1 whole square. So which is given as what we can say now here, data of a square. This is square. Now tell me. So how much it is? 2 square. This is 4. Sorry. How much this is? Yeah, this is 2 square, which is a 4, right? So then which is given as data of a power 8. So which is given as data of a power 8. Fine, all of you? Right. Chalo, next problem. If A is a non-zero column matrix of order m cross 1 and B is a non-zero row matrix of order 1 cross n. Okay, now they are asking to find the rank of AB. Tell me now, A matrix. Consider this A matrix, which is a column matrix. So it has a m rows. We need to have, let us consider which will be a something x comma y comma z. For understanding purpose, which we have taken this as like a 3 cross 1 we have taken. And B is a row matrix. Let us call this is A comma B. So which are taken as a 2 cross, sorry, 1 cross 2 I have taken. I have taken as a 1 cross 2 I have taken. Now this is AB we need to do, which is given as x, y, z and AB. Now you can tell me now here, we can multiply this thing here, this rows with columns. So what I will get now here, this is AX, next this is AY and AZ and BX, BY and BZ, all of you. Now if you see carefully here, in this row we can take out A common and here B common. So this is AB we have taken common. Then what here left out now here, X, X, Y, Y, Z, Z. Yes, now here. Now you can see now in this row I can take X common. So this result which will becomes what now, AB into X and Y also common. Then it will becomes 1, 1, 1, 1, 1, 1. Like this will happen now. And thereafter which is given as AB into XY. So let us, and you can see now we can apply the row operations. It will becomes 1, 1, 0, 0, 0, 0. Like this will happen or not? So you can see now, tell me the number of non-zero rows. Now here we have a 2 non-zero rows. We have, sorry, only 1 non-zero row is there now. So the rank of the matrix. So the rank of the matrix AB, which is equal to, tell me now how much it is, a 1. Done. Next problem. We have completed the linear algebra problems. Let's move to the probability problems. And see this problem here. 3 electric lamps are to be fitted in a room. So we need to fit the 3 lamps has to be fitted. And 3 bulbs are chosen at random from 10 bulbs. Totally 10 bulbs are there. In these 6 are good, and that means 4 are bad, defective. Right. The chance that the room has to be lightened. The room has to be light for the room has to be lightened. That means at least one of the bulb has to glow. So we have fitted 3 bulbs as fitted. At least one bulb glow, room is lightened, and 2 bulbs are there good, also room is lightened, and 3 are also room is lightened. And we need to see the room has to be lightened here. And for this case, what I can do here, that means we need to select the at least one good bulb, two good bulb, three good bulb instead of that. So what I am doing is, now the will let us find out this thing as a uh, 1 minus none concept we can apply. Means what now here, let us say that there is no good bulbs are there, all are defective bulbs only, all are defective bulbs only. So how many bulbs has to be selected now, tell me? What is the probability that the room should not be lightened? That means for that we need to select all are defective bulbs. How many ways I can do here? That is 4C3 by 10C3. This is the probability, so that we need to get the defective bulb. All three are defective, but the room has to be lightened now here. So what is the probability? Tell me now here. That is 1 minus 4C3 by 10C3. All of you, 1 minus 4C3 by 10C3. Now let's simplify this thing. You can get this thing here. 1 minus, what we can say here, 4 into 3 into 2 into 1 upon, so this is 3 into 2 into 1 by, and 10. So this is 10 into 9 into 8 by 3 into 2 into 1. So simplify this thing here, which we will get it as 1 minus, that is 1 by 30, which is equal to 29 by 30. Next problem. Now see this thing here, two numbers are selected at random from 1 to 100 without replacement. The probability that minimum of two numbers is less than 70. Minimum of two numbers is less than 70. So we have a numbers 1 to 100. We have 1 to 100 we have without replacement. The probability that the minimum of the two numbers is less than 70. So somewhere we have a 70 is there. Now you see this thing, look at now here. If you observe carefully, we need to select the two numbers has to select. Two numbers has to select now here. Now the two numbers has to be select. Now the sum is less than 70. So what I am doing is, I am selecting these numbers. Now if I select the numbers from in between 70 to 100, let us say, if I selected numbers in between 70 to 100, then I can definitely say that the sum is always, so here the one of the number is greater than this thing. So here we need to get this thing at least, so minimum of the two numbers is less than 70, we need to select. So for that purpose, what I am doing, I am selecting a number from here, one number from in between 70 to 100 I have selected. Let us consider. And the second number also I have selected from in between 70 to 100. That means what happens now here, minimum of this thing is less than 70 will come up, greater than 70 will come. So it will becomes greater than or equal to 70. So I need to get a number. So I need to get the two numbers. Those two numbers, the minimum of the two numbers must be less than 70 we need. This thing what I am doing is, that is 1 minus, can I write this thing as this value greater than or equal to 70? Greater than or equal to 70. If I select a number in between 70 to 100, what happens now? I will definitely get a minimum numbers is greater than or equal to 70 will come, isn't it? So here, which is given as, tell me now here, what is the probability of selecting the two numbers the minimum is greater than 70, that is 1 minus what I can say, how many numbers are there in between 70 to 100? 30 or 31? Including 71 to 100 means that is 30, but 70 also included now. So here 70 also included, 70 to 100, 70 included, 100 also included, close bracket. Then how many numbers are there totally? 31 numbers are there. So means we need to select the 31 C2 by 100 C2. This is the probability of the minimum of the two numbers is less than 70. So the option is fourth option. Now two symmetrical dice are thrown at a time. If the sum of the points is 7, the chance that one of them will show a face 2 points, number 2. So first of all, you tell me the sample space here. Here this is conditional probability sample space. They are saying that sum is 7. For the sum 7, now we should get the combinations are 1 comma 6, 2 comma 5 and 3 comma 4. Next 4 comma 3. Right. Next 5 comma 2. Next 6 comma 1. Like this hoga na? 1, 2, 3, 4, 5, 6. Totally sample space 6. In this we need to get now here here one of the face much to show that 2. That means here we have a 2, here we have a 2. So that means probability which is given as favorable events are 2 and sample space events are 6. So which is given as what? 1 by 3. Next, 3 students A, B, C are to take the part in a swimming competition. The probability of A winning or B winning each is 3 times the probability of C winning. So means if I call the probability of C winning, if I call this as X, now you tell me now probability of A winning which is equal to 3x and probability of B winning and which is also equal to 3x. Now as we know here, so here sum of the all the probabilities which is equal to 1. So that means what we can say now here, x plus 3x plus 3x which is equal to 1. So that is x is equal to what you tell me now, 1 by 7. And what is the x you tell me? X is nothing but probability of C winning. What they ask now, C winning only they ask now here. So probability of C winning which is equal to 1 by 7. Next, a class has a 15 boys and 5 girls. Suppose 3 students are selected. 3 students are selected random from the class. The probability that there are 2 boys and 1 girl. So we need to get the 2 boys we should get and 1 girl we should get. So let us see this thing. Totally how many are there here? You can see 15 boys are there and 5 girls are there. So we can select the from boys from, we will get a boys. How many boys required you tell me now here? 15 C2. 15 C2, yes. Next girls, how many here? 5 C1. By total is how much we have? How many? 20 na? 20 C3. That's all. 15 C2. So simplify this thing, get this answer. Right. And to simplify, you will get this answer which is equal to 35 by 76. Option A. Next, now we'll move to the calculus problems. Right. Now take this thing here. Limit log of, so you can tell me now here, limit x tends to 0 log of, we have log of 1 plus x by x. So which we can split it as, which we can say log of 1 plus x minus, I can write this thing as log x, isn't it? Log of a by b equal log a minus log b. So then log of, which will be given as log of 1 plus x, which we can make this as a plus, and I can take this thing as log of 1 by x, I can write, you tell me. So then which is given as limit is there, which is given as now in the form of log of a plus b, which is equal to log of ab, we can write now here. So this thing which we can come it as 1 by x into log of 1 plus x. All of you tell me this thing here. Okay, log a plus log b, and which is given as log of a plus b, log of ab, isn't it? Now you can see this thing here. Now this we have modified as usual, limit x tends to 0 is there, and which is given as log of, which we can write it as log of 1 plus x whole power 1 by x. Tell me this thing. 1 plus x whole power 1 by x. And as you might know here, limit x tends to 0, 1 plus x whole power 1 by x. So this value which is equal to e, isn't it? This value which is equal to e. So the limit x tends to 0, what is this, you tell me now here? Log of, so this value which is equal to e now here, that is log, here base is e and this is also e. So tell me now log, now it is log e of 1. So here this value, as we know here, this is log e and e, which is equal to 1 now. So and log 1 which is equal to 0. So option 1. Next, the value of this limit x tends to 2. Limit x tends to 2. Let's see this thing. What is this value? Now, limit x tending to 2, which is given as 2 power x plus 2 cube by 2 power x minus 6 upon, which we can say 1 by root 2 power x minus 2 power 1 by 2 power x. Now take LCM and simplify this thing. So then 2 power 2, 2 power 2x plus 2 cube minus 2 power x into 6 by, that is root 2 into 2 power x minus 2. Check this thing all of you. So this means, which will get this as 4 power x plus 8 minus 6 into 2 power x by, so which is equal to square root of 2 power x minus 2. And if I substitute the given x value to here, directly we'll get 0 by 0 form. So can I go for L'Hospital rule? We'll go for LH rule now. Tell me what we'll get now here. Derivative of this 4x, which is nothing but 4 power x into, that is log 4 plus derivative 0 minus 6 into 2 power x into log 2. Now root x, which is given as 1 by 2 power 2x, 1 by, so here, and then what we can say now here, which is equal to log 2. minus 0. Now you can tell me now here this thing log 4 we can say as log 2 whole square. So it will becomes what we can say now here, that is 2 into 4 power x into log 2 minus 6 into 2 power x into log 2 by, so here 1 by 2 into square root of 2 power x into log 2. So I can cancel the log 2 in both sides. If I cancel this log 2 here, this is only for this only now. If I cancel this log 2 here, so tell me now here limit x tends to 2, what here left out now here, 2 into 4 power x minus 6 into 2 power x by 1 by 2 into what we have is square root of 2 power x. Isn't it, tell me here? Now substitute the value of 2 here. If I replace this value, so x value, x is equal to 2, then how much you will get? You see this thing here. So this is 2 into 4 square minus 6 into what now here? 6 into 2 square by, that is 1 by 2 into, which you will get 1 by 2, isn't it? 1 by 2 will come. So simplify this equation here, and what will get now here? So here that is 2 into 16 minus 1 second, here 1 second, one small correction we made it here, I think so. Look at now, this is small correction here. Yeah, what is this thing here? This derivative. So here this is 2 power x by 2, isn't it? So this derivative which is given as 2 power x by 2 into 1 by 2. Yes. So this small correction here. This is 2 power x by 2. This is 2 power x by 2 into 1 by 2. Fine. So this one, so this is 2 power x by 2 into 1 by 2. Now here this is 2 power x by 2 into 1 by 2. Now replace this value, x value 2, so there is 2 power 1 into 1 by 2. So which will get now 6 into 4. So what I will get now here, this is 32 minus 24 now. How much will get here? You can see plus 8. So this is the option. Next, see this thing, limit x tends to 0. Here if I substitute, we will get 0 by 0 form now. So directly we can go for LH rule. Directly we can go for this LH rule. Tell me now here. That is limit x tends to 0. So that is e power x sin x derivative, which is a cos x, and minus 0 by, so log x, that is 1 by 1 plus x, and limit x tends to 0, so which will come it as 1 plus e power 0, which is 1, so, and which is equal to cos x, cos 0, which is also equal to 1 by, so it is 1 by 1 plus 0. So how much will get, you tell me? 2. Next, here 10 power x minus 2 power x. Here 10 power x minus 2 power x minus 5 power x plus 1 by x into tan x. Now I am taking limit x tends to 0. If you have taken the 2 power x, we have taken common, let us say. If you have taken the 2 power x, we have taken common in these two here, which I will get the 5 power x minus 1. If I take minus 1 common, then again here is a 5 power x minus 1 hoga, x into tan x. Now let us do this factorizations here. X tends to 0, so this is 5 power x minus 1 into 2 power x minus 1 by x into tan x. X into tan x. Now which we can split it as limit x tends to 0. So this is 5 power x minus 1 and 2 power x minus 1, 5 power minus x, if we say here, and I am modifying this thing as 1 by tan x divided with x and multiply with x. Now you see this thing here. Now this limit is applicable for all the three functions you see. So that means what I will get, you tell me now here, which is nothing but log 5 and this is log 2, and x tends to 0, tan x by x is 1, so which is given as log 10. Next. Now, so here in this problem what we are doing is, I am simply multiplying the whole equation with x square plus ax plus x a square plus like a rationalizations to get the a square plus minus b square form by square root of x square plus ax plus a square plus square root of x square plus a square. And if we multiply it, so what I will get, you tell me now here. So if we multiply this thing here, so what I will get now here, this is x square ax plus a square minus x square plus a square by, so square root of x square plus ax plus a square plus square root of x square plus a square. Now you tell me now here. So x square a square will get cancelled now here. So numerator what we have left out, you see this thing here, this is ax by square root of a square plus ax plus x square plus square root of x square plus a square. Now limit x tends to infinity. So if I take out this x common in the denominator here, x, so what we have left out here, you can see. Now this is 1 plus, that is a by x plus a by x whole square, and here also we have taken now here x common, that is square root of, you can see this is 1 plus a by x whole square. X will get cancelled. Next, x will get cancelled. Now if you substitute the limit x tends to infinity, so then what I will get, this value, tell me here, which is nothing but a by, so square root of 1, So this is 1 plus square root of 1 will come now, which is nothing but a by 2. Fine? Yeah. So that's for the today's sessions, and we'll meet in the next session. Okay then, see you, bye bye. All of you do like, share and subscribe for the Dakshin Engineer Junction.